Cek. Cek, cek. Tes. No.
Tes, tes.
Tes, tes. Ladies and gentlemen, welcome to the second day of ISITIA 2024. Once again, I would like to greet all our guests and participants for today's event, whether they are joining in person or online. Good morning to everyone here attending in Lombok Raya Hotel of Mataram. And in the morning, we already had the second technical session, and now we will be having our third and fourth keynote speeches. These keynote sessions will also be held on-site and online, and then followed by a discussion session. So to all participants, online or offline, whether you have comments or questions, you may now ask your questions in the chat box for the participants online in the Zoom or YouTube. And to people who are attending on-site, you may raise your hand in the discussion session if you ever have any questions. Now, let us welcome our third keynote speaker, Professor Wan-Jen Huang from the National Sun Yat-sen University of Taiwan, along with our moderator, Dr. Ahmad Sirojudin from ITS Indonesia.
Okay, good morning, ladies and gentlemen. We are now in the third keynote session of the overall ISITIA 2024 event. Now, before we start the keynote session, let me introduce our third keynote, which is Professor Wan-Jen Huang. Professor Wan-Jen Huang received her PhD degree in the Department of Electrical Engineering from the University of Southern California in 2008. She is currently working as an associate professor and the chairman of the Institute of Communication Engineering at the National Sun Yat-sen University in Taiwan. She is now the vice chair of the IEEE Communication Society Tainan chapter and joins the editorial board of an reputable international journal, APSIPA. Her research interests include signal estimation and detection and baseband signal processing of wireless communication systems such as massive MIMO, reconfigurable intelligent surfaces or RIS, and cooperative communications, and so on. She supervised several Indonesian students, which is 5 master students and 2 PhD students. She serves as the chairman of the ICE at the NSYSU from 2021 to 2024. So, without further ado, let's welcome to Professor Wan-Jen Huang to give her talk.
Thank you for Dr. Sirojudin's introduction. Good morning. Selamat pagi. Now, this is my first time to speak in Indonesian language. My name is Wan-Jen Huang from National Sun Yat-sen University in Kaohsiung, Taiwan. I'm appreciate the committee from the ITS to invite me here. And it's my great honor to share my experience on the AI application in telecommunication system and the industrial collaborations. Oh, okay. Thank you. Yeah, I think that the symposium is for double E area, so maybe some of you come from the computer science area, so maybe you are more familiar with me, than me about the topic of artificial intelligence. So first of all, let's think, what is intelligent? The so-called intelligent, actually it has a variety of definitions. In general, it refers to the ability to think, to learn, and to solve a problem. And then what is artificial intelligence? Artificial intelligence, usually it refers that we want the computer to think and to learn and to solve a problem. So it refers, we want the computer to mimic the function of human brain. So it usually refers to the ability of a computer to solve a problem and to act rationally and to act like humans. Yeah. So next page, please. Yeah, thank you. And actually, artificial intelligence, AI, is not a new term. Also, it is very, very popular now, but actually it has a long history. So the term of artificial intelligence was firstly pointed out by Professor John McCarthy from Stanford University. And the definition at that time was, sorry, the previous slide. Yeah, thank you. The definition of AI by Professor John McCarthy is that it is the science and the technology to making intelligent machine. Okay, so actually, as early as 1968, a simple computer based on a simple neural network was built, and the computer learns something to accomplish some task, some simple task through heuristical trial and error. So actually, at that time, the AI is not that intelligent because every AI model was trained through the trial and error. So after several years, the AI winter arrived. But in 1970s, because the computer become faster and faster, so another AI summer arrived. Okay, so around 1980s, some neural network let use backward propagation to train it to train itself was widely used. So another AI summer arrived. So at that time, including the development of dark blue. I think maybe some professors have learned dark blue. It was developed by IBM company, and the dark blue system, it beat the world chess champion at that time. Okay, but actually after a few years, another the AI summer ends with another AI winter. Okay, so currently AI becomes very, very popular because in the late of 1990s, because the GPU, the graphic cards is widely used, and also the big data become very popular. So currently, the AI, especially the AI based on the deep learning algorithm, has impressive breakthrough in various applications. And the application including the area of robotic, Internet of Things, analytics of image, graph, audio, the image detection or image synthesis, and the social network analysis, machine translation, visualization, and autonomous vehicles. Actually, there are many kind of AI application, not only in electrical engineering field, but also maybe in the medical, in music, in many multimedia area. So, what is AI? Usually, when we mention of artificial intelligence, we will mention AI with machine learning interchangeably. But actually, machine learning is a subset of AI. Okay, so AI is, in general, means the ability of a computer to mimic human thought while carrying out some task in real world. Okay, and then what is the so-called machine learning? Machine learning is actually some technology or some algorithm to let allow some computer or some software to perform some task. For example, recognize some pattern or classification, and or make some decision. So, but the machine learning algorithm usually they can improve themselves based on through the some previous experience and the data they received. Okay. And among the variety of machine learning algorithms, there are a subset of algorithm called deep learning. And deep learning is a subfield of machine learning, which is based on the artificial neural network, and it is a it has multi-layered structure. So it can perform some more complicated tasks. So for example, currently the ChatGPT is very popular, and it is based on the deep learning based method. And most machine learning or deep learning algorithm can be classified into three classifications, including supervised learning, unsupervised learning, and reinforcement learning. For supervised learning, the model is usually trained using labeled data. So if we want to train the model for supervised learning, we need a lot of data set, which accompanied with some label. So sometimes the challenging is based on how to get the labeled data, because maybe we may need some human power to label the data. But currently, maybe there are some other technology to automatically label the data that will facilitate the development for supervised learning. Okay, so usually the supervised learning is applied in to solve the classification task or regression task. So, for example, for the classification tasks, KNN, K nearest neighbor algorithm is a very famous one, and for regression, maybe SVM model is a very famous one. But there's another kind of learning called unsupervised learning. In this learning, the model can be trained by unlabeled data. So as long as they know how good is the current model, then they can gradually achieve the better and better performance. So for example, usually the unsupervised learning is used to accomplish some clustering task. But actually, unsupervised learning can also to perform classification and regression. In my group, some of my students, they use unsupervised learning to perform regression task. Okay. So there's a famous clustering algorithm called K-mean algorithm. It is a famous machine learning method used to solve the clustering problem. And there's another kind of learning method called reinforcement learning. It is also very popular now. So in reinforcement learning model, the model mimic how the human think. So usually when we want to learn something, we will try and see how good it is, or we will use some try and error. So actually, the reinforcement learning method, they mimic the try and error procedure. Okay, so in this model, there is one agent. The agent will generate some action, or it will generate it will make some decision. That is an action, and then if we do the action, then we can get an updated state and updated feedback after interacting with the environment. And then the agent can update or can optimize its model again using the updated feedback and updated state. So it will try and learn how good it is, and then try again and learn again. So eventually it will get converged. So this model is trained based on the updated state and the feedback. So for example, some Q-learning or some deep Q-learning method is the famous reinforcement learning method. Okay, so now we review some history and some background for the machine learning. The next is why we need to use machine learning in communication system. So let's briefly look at the trend of mobile communication system. So maybe here, many professor experienced the mobile system from 1G, 2G, to now we are in 5G, right? And actually, when 3G or 4G arrive, we have to have a smartphone. So with the development of and popular of the smartphone, we need more and more data rate, because we sometimes we need to watch the video, or we want to have some video conferencing with our friend. So to achieve higher spatial efficiency, higher data rate, and to service more and more users, MIMO technology has been developed actually from 4G. And then to 5G, we have massive MIMO. Massive MIMO means we have multiple antenna at the transmitter, and we have multiple antennas at the receiver. But in 4G, in 4G standard, the number of antenna is at most maybe 8. But that's not enough to fulfill our requirement of high-speed transmission. And because now everyone maybe has more than one device needs to be online. Maybe you will have your cell phone, you will have iPad, you will have your some device, some watch or some glasses need to be online. So in 5G we have massive MIMO. So in massive MIMO, the base station may have hundreds of antennas, and then it may serve tens of the users, and each user has maybe has several antennas. So the system becomes very large. So in this case, the optimization or the signal processing in baseband will demand more higher and higher computation complexity. So that's why we are thinking whether AI or machine learning or deep learning can help us to solve this problem. So, yeah, too much. Yeah, in the past we usually use model-based communication system. This is the block diagram for baseband physical layer signal processing for MIMO communication system. So suppose we want to transmit several data streams, and the data stream will be passed through a channel encoder. The channel encoder is to to add up some error correction code to protect the data. And then we pass through a modulator to have some higher, if we use some high-level modulation, for example, 16 QAM or 1024 QAM, then we can have a higher transmission rate. And after that, if we have multiple antenna, we may adopt some beamforming or some space-time signal processing scheme to leverage the spatial multiplexing gain or spatial diversity gain. And in 5G or beyond 5G or 6G, actually, sometimes we will think if the number of antenna is not enough, maybe the transmission of the MIMO system can be assisted by a reconfigurable intelligent surface. We call it RIS. RIS is composed of several reflected elements. It looks like a mirror. It reflects the signal, but it can have produce some phase shifting of the incident signal such that the signal can coherently combine the receiver, so we can strengthen the received signals, strengthen the received signal. And at the receiver side, we may first perform some space-time processing to decouple those data symbols, and then we need to perform some channel estimation to learn what is the channel coefficient of the environment. The channel coefficient is usually used for demodulation or MIMO detection. And sometimes the estimated channel information will be feedback to the transmitter to design the precoder. Okay, and eventually the demodulated symbol will pass through the channel decoder. So this is the overall procedure for baseband signal processing in a communication system. So in the past, every researcher, maybe they focus on one block. For example, my research is focused on space-time precoder, decoder, and sometimes channel estimation. And some of my colleagues work on MIMO detection. And some of my colleagues work on channel encoder and decoder. So actually, the communication system is a model-based, and everyone focus on their specific block, and we optimize each block individually. Okay. But now, if the conventional model-based method, the researcher or the scholar will develop some algorithm to perform, for example, MIMO detection. We may use some maximum likelihood detection or some other AMP algorithm, ADM algorithm to fasten or to reduce the complexity for the MIMO detection. And maybe we will use some other algorithm, for example, least square or MMSE to estimate the channel coefficient. Or we may use some MIMO decoder, maximum likelihood decoder, or maybe channel decoder, or maybe there are some other many different kinds of maximum likelihood decoder for channel decoder. And for the precoder and the decoder design, in the past we use some optimization-based method. For example, we use gradient-based method, or we use CVX, convex optimization-based method, to optimize the precoder and the decoder. Sometimes we will have some objective. So actually each scholar will focus on one of the term. But the issue is that if we go to the 5G or beyond 5G or 6G, the number of antenna is significantly increased. So it is very difficult to estimate the channel coefficient now, especially if we have a RIS, because RIS is a passive. RIS consists of a passive element. So for the RIS system, it is very difficult to estimate average between one antenna and each RIS element. Okay, and also, if we have massive MIMO, we can allow more data stream transmitted at the same time. So the demodulation require very high complexity. Also, the design MIMO precoder and the decoder will become very challenging if the number of antenna and the number of read elements increase quite a lot. So actually, if we look at some literature, you will find that in recent years, many learning-based system design was proposed for wireless communication. For example, in the precoder and the decoder design, all of the learning-based supervised, unsupervised, and the reinforcement learning were employed to design the precoder and decoder. And similar for the channel estimation and the MIMO detection and the channel decoder, some supervised learning method was adopted here. And actually, moreover, you can find that at the receiver, because the signal processing at the receiver is more required higher complexity. So the learning-based method is especially at the receiver end. And we see some literature because in the receiver, if we want to employ learning base for each block, it may not that efficient. So actually, you can find that some end-to-end receiver design was proposed using learning-based method. Okay. So the next, I will share my views of the precoding and decoding design in recent MIMO work. Actually, published in 2022. The work is published by yeah. And at that time, we consider a research-assisted MIMO system. We have a MIMO transmitter, multiple antenna transmitter, multiple antenna receiver, and the transmission is assisted by a reed. So assume that the channel coefficient are perfectly known. So assume that we can perform the channel estimation. Then Jadine proposed one dimensional-wise sinusoidal maximization algorithm to optimize the precoder. And we also compare it with some other gradient-based some other optimization-based method. For example, ADMM and the gradient ascent method. And we also compare it with exhaustive grid search. So we find that actually from the achievable rate, it means the DSM and also the search. As you can see this figure, if the number of read elements increase, then we can see that the exhaustive search, the computational complexity for exhaustive research will grow exponentially. So it is it will be very hard to perform the research in practical. But the proposed DSM algorithm will come even though we increase the number of read elements. So I think this is very nice. Yeah. At that time, some other students, they tried to use the optimize the precoder. So we assume that the input is the channel information, and then we use codebook-based method. So we have a big book codebook. Each code word is one candidate of the precoder. So the DNN try to select the best code word to perform the precoding. And through the simulation, we see that the DNN can achieve 98% achievable rate compared with the exhaustive search, but the running time is much less compared with the exhaustive search. So this is our first trial. Using the deep learning based method to design the precoder. But at that time, we discussed of my colleague. My colleague, he has one big MIMO OTA, over-the-air platform, and he did the measurement of the MIMO signal. He told me that for the RIS system, it is very hard to estimate the channel from individually from the transmitter to RIS, and from RIS to the receiver. Yeah, because RIS can only reflect the signal, but it is hard to individually estimate the channel. So actually, he told me that he cannot estimate the channel. So it would be a challenging in practical to apply both algorithms in his platform. Okay. Yeah, so thank you. So because the estimation of two separate links, the link from transmitter to RIS and the link from RIS to receiver is very difficult. Yeah. So later on, we consider some learning-based algorithm to design the precoding based on the received pilot signal directly. Yeah, because over the OTA, over the practical system, we can send some pilot signal to the receiver, and the receiver can collect some received pilot signal. So we want to let the received pilot signal as the input of the neural network, and then we use those input to generate a precoder parameter for the transmitter. Okay. So in recent year, our new design is to optimize the precoder and the decoder based on the received pilot signal. And we tried many different kind of learning-based methods, including reinforcement learning, DTPG, PPO, or supervised learning, including DNN, MLP, or green learning method. And we want to, the output of those algorithm is the optimal precoding parameters. But how to train the model? When we train the model, actually, yeah. So when for the supervised learning, maybe we need some label, or yes, to optimize it. And for reinforcement learning, maybe sometimes we need to know how good is the current parameter. So for reinforcement learning, we need to design the pilot signal properly such that we can use the received signal to evaluate how good is current signal and how much is current transmission rate. And when we train the model, we use another neural network to estimate the reward, or sometimes we design the pilot signal such that the reward can be estimated easily. Yeah. And for supervised learning, when we train the neural network, we randomly generate some channel realization, and based on the data set of channel realization, then we use current optimization-based method to generate the label for code word. Okay, and then we use supervised learning to approach the optimal solution. So this is the methodology we use. Yeah, and how to generate a label? We use Dr. Judy's DSM algorithm. So this is some result of deep learning-based learning. We tried LSTM model, CNN model, and the DNN model, and the input is the received signal. And it turns out that those both DNN and LSTM can achieve good performance compared with the optimal exhaustive search algorithm. Here we use codebook-based method. Yes, and so and then we consider a more complicated system. In this system, there are multiple users and there are multiple reads. So maybe some user is served by a different reads. Okay. So because the deep learning DNN-based method, LSTM, CNN, and DNN, they usually perform some classification task. So they can just help us to select a base code word. So our precoder parameter is limited on those finite set of the code word. But we think this can, there could be some quantization error. So if we want to achieve better performance, maybe we should use some other regression model. So we use DTPG model. Okay. So, and we compare with optimization-based method, because, including BCD, MMS EPI, and we find that because this algorithm is iterative algorithm, so the complexity will going high if the number of iteration increase. So if we compare three methods based on the same complexity, then we find that he can achieve the optimal performance compared with those optimization-based methods. But for DTPG method, because we don't know what is the real optimal solution, so it would be difficult to compare with the optimal transmission rate. Okay, but so in the above algorithm, we use deep learning based deep neural network, or we use deep reinforcement learning. But the deep learning based method actually is operated based on neural network. And if we want to train the parameter for the neural network, we need to use backpropagation. So actually the training cost is very high. And usually the model size, the number of neuron we use is quite a lot. So actually, for example, for the DTPG, it takes a lot of time to run the simulation. So recently we are thinking to use some lightweight machine learning or lightweight learning method. So we consider green learning based optimization. And green learning was proposed by my supervisor my PhD supervisor in USC, Professor J. Guo, and it contains 3 modules. In the first module, it extracts the representation from the input data. For example, if we have several input data, we can generate. When we train the model, we can randomly generate several input data, and then we use principal component analysis, or we use maybe Fourier transform to find the dominant subspace of the input data. Then we can reduce the dimensionality of the input data. So for the representation, the dimensionality can be greatly reduced if the data lies on a small set of subspace. Okay. And in the second module, we perform supervised feature learning. Then, because although we find the dominant subspace of the input data, but not every is highly correlated to the label we want to generate. Okay, so in the each representative parameter, we have whether they are highly correlated or not. If some representation is not correlated to our label, then we will remove it. So the remaining important or prominent representation is called feature. So now from the first stage to second stage, we gradually select some important feature for our input data. And then we perform some regular lightweight machine learning algorithm, which is not based on neuron and which does not require backward propagation algorithm to train it. So here, you would usually, for example, in our case, we select attributes. So the training is one shot. We just need to set the training data and give the label, and in one shot, it can train every parameter very quickly. So this is some simulation result. So actually, green learning contains two stages. The first stage is to extract the feature, and the next one is followed by decision learning. Okay, so this is some result. We compared it with Dr. Sirajudeen's DSM algorithm, and we compared with DNN and random selection. And we can see that green learning and DNN has very similar performance, but it is better than slightly better than DNN. And of course, because the label we generated comes from Judeen's algorithm, so we cannot have better performance. But if you see you check the complexity, the green learning method requires simply 1% to 2% number of floating point operation compared with DNN. Yeah. So we can see that although we know in the past experience we know that DNN can calculate the parameter quickly, but actually if we adopt green learning, we can get a much better speed and get a better result, and the training complexity is even lower. So this is the method that we are trying. Okay, so sorry for such a long time. And lastly, let me share some my experience for industrial collaboration using AI. Yeah, actually, I work in NSYSU for 16 years, and at the beginning, it's very hard to find some industrial collaboration. But in current years, because now the IT company industry and some communication industry becomes very good development in Taiwan. So they contact with the university to look for some collaboration. So for example, in recent year, we have some collaboration with Qualcomm. Qualcomm held Qualcomm Taiwan University research program. And in this research program, every year, we can submit a project, some proposal to Qualcomm, and actually in this program we can submit a proposal related to some more advanced technology. They want something new, something advanced, and for their reference. And also we collaborate with the ASE company. ASE Corporation is one local industry in Kaohsiung. And it focuses on the packaging and manufacturing, packaging, and the testing of the chipset. Yeah, and because when they testing some chipset, they need some algorithm to fasten or to speed up the testing method. So they contact us to jointly develop some algorithms. So this is the project we are doing. Now we are in the third year with ASE. And also in Taiwan we have ITRI, Industrial Technology Research Institute. It is funded by funded by the government. So we collaborate with the department who will join the stand-up meeting. So they want us to jointly develop some system-level simulator. And also we collaborate with CTC, Telecom Technology Center. It is partially operated by the government as well. And we help them to study the coexistence distance of 5G private network using simulation. So actually, among those projects, the Qualcomm project has the highest flexibility. It's just look like our research, because when we publish a paper, we always want to propose a novel things. But when we submit some the Qualcomm project, we need to submit something new, novel, but it should be practical for industrial use. So in this year, we developed some deep reinforcement learning based method for star reads assisted MIMO system. And actually this work is performed by another Indonesia student, PhD student. And now so in Qualcomm project, we just need to report our progress or our result to them every 6 months. So it has very high flexibility. But the Qualcomm Taiwan University project is based on some agreement between Qualcomm and the Taiwan government. So I'm not sure how long will it last. And another long-term project is the project with ASE company. Actually, when we collaborate with the company, it is more stressed. We need to have regular meeting with them every 2 weeks to report our progress. And because they pay money to us to solve problem for them, so every 2 weeks they expect to look some result. So actually, the project with conventional or traditional industry is more straight. Okay. So in this project, the company, they want to develop the near field chamber. So what is far field and near field? If we have an antenna, but we want to test whether it is good or it is ideal or not, it is good or defect, we can measure the pattern, the beam pattern at some point. So if the measuring distance is lower than 2D squared over the wavelength, D means the dimension of the antenna, then this measuring range is near field. And if the distance is far from this range, then this is far field. And because ASE is the company for manufacturing and packaging and testing, they want to develop some testing method for mass production. So they want to develop some testing system which has very small size. So they contact us to jointly develop some near field OTA box. The box is very small. It's around maybe 12 centimeter. Yeah, but so actually we study different kind of near field beam pattern. So this is the ideal near field measurement, and if the antenna module has some or antenna chipset has some defect, you can see that the measurement has different pattern. So the problem look like a pattern recognition. Right, so we developed some learning-based method to help them detect the defect module facially. And also, we developed some algorithm to help them reduce the number of sample because they want to speed up the measurement, the testing time. So we need to help them to reduce the number of sample. So in this program, we under near field measurement, we can reduce up to 30% of the measurement. But because currently the near field test box is not developed very well, so in the next year, they contact us again. They want to develop some fast algorithm to test the antenna chip based on far field measurement. So the far field radiation pattern look like this one. Yesterday I joined some communication session. I see some professor, their report has similar figure, right? So this is the far field radiation pattern for ideal antenna. Of course, we will collect several different kind of far field radiation pattern for defected DUT. So based on the ideal pattern, this is the 2D map for this pattern. So we use CNN and CNN to detect whether the chipset has defect, or we can detect what kind of defect is it. Okay. Yeah, and I think the most important of all is that they help us to find some critical measurement, because if we want to scan the complete radiation pattern, it requires over 66,000 measurements. It takes a lot of time. So based on the distribution between the difference of distribution between the ideal chipset and the defective chipset, we gradually summarize some critical observation point or critical measurement position for them, such that they just need to measure the signal on some specific location. Then they can detect whether the chipset has defect or not. Okay, so we can reduce the number of observations from 66,000 points to 5 points. And then we also deliver some software for them to find the optimal observation point by themselves. Okay, so yeah, and this is the final remark, the last page. So in this talk, actually we first introduced AI, and AI is some technology which can solve the complicated problem, including the complicated designing or signal processing in wireless communication. And we also share our research experience on applying the AI-based method in pre-coding design and decoding design. And also, when we collaborate with the industry, actually they always welcome some novel or some technology new, because currently they may not have the engineering who is familiar with those AI skills. So if they collaborate with the university, maybe they can try those new methodology to solve their problem. Yeah, so actually currently the AI is also a very favorable tool to enhance the performance when we collaborate with the industry. And thank you for attending the talk. So if you have any question, feel free to ask me.
Okay, thank you very much for Professor Wan-Jen Huang for your very inspiring presentations. I think we get so many new insight here. So the next session, it will be the Q&A sessions. If any audience have some questions, I think you can raise your hand. Or maybe is there any question from online participants? Okay, there is questions from Dr. Devi.
Thank you very much. I have one question. Regarding RIS, you mentioned that it can be used for reflecting signals. Can it also be used for focusing the signals? For instance, I work on radar radar systems, and for surveillance, we usually need to have a very narrow beam width. Is it possible that we use the same concept as we use in communication with RIS, with RIS, but we use it to make the beams narrower? Can it be used for that?
Sure, you can do that. Actually, currently there is another popular topic called joint communication and sensing. And for the sensing, it is similar to radar system.
Yes.
So actually, RIS is using sensing as well. So because we can adjust the phase shift of the reflected signal, so we can use the reflected signal. We can design the phase shift to focus the signal to some point or to narrow some beam width. So the more element do we have, then we can have an even narrower beam.
So for example, if we have a MIMO radar with multiple transmitters, could we reduce the numbers of transmitters and using the RIS instead for replacing the number of...
Sure,
okay.
we can do that.
But that's interesting.
Usually, if the line of sight is blocked, usually RIS can be helpful.
Oh, okay.
Right? Because for the MIMO radar, it requires line of sight.
Yeah.
But if the line of sight is blocked, then the RIS can reflect and then narrow the beam.
Yeah.
It can do that.
But for radar, actually, we only need to catch the reflections of the target. So I think it's enough to...
I think...
Yeah.
Yes.
That would be useful, I think.
It is also
interesting
possible.
to have.
Yes, because I know some researchers, they use RIS to enhance some localization.
Okay.
Yeah, maybe it is very similar to the MIMO radar, right?
Yeah. Okay, thank you very much.
Thank you for the question.
Okay, is there any question? Okay, from Dr.rer.nat.
Thank you very much, Pak Judin, and very interesting presentation. Because my background is not in telecommunication engineering, so I will ask about the power consumption actually. So by adding some advanced feature like AI in telecommunication system, is there any more power required to operate this device?
Power amplifier?
Yeah, power consumption. I mean, by adding some AI feature in the device, do this consume more power to operate the device? Sure.
If we use, actually, currently the most deep learning use GPU, NVIDIA, something like that, and the operation of GPU consumes higher power. So that's why later on the green learning comes out, because it won't reduce the carbon footprint. So actually, I heard that for the GPT, the company ChatGPT use AI to have some generative AI. I heard that the cost for the power every day is several million US dollar. So it does consume a lot of powers.
Okay, so that means this will be our task then in power engineering, yeah,
Yes.
to make more efficient
Yes.
energy consumption. Anyway, thank you very much.
Thank you.
Okay, is there any question? Okay, from Dr. Hendra.
Thank you, Professor Huang, for your excellent explanation. Yeah. I'm also not from telecommunication area, yeah, but I'm just curious, is there any deep CNN model available for transfer learning in the application, in the telecommunication? And also, is it can be real time to apply DNN in telecommunication application, or you do learning in offline, something like that?
Yeah, actually, I do not see real-time implementation from the literature, but it depends on the environment. So if the statistical property of the environment doesn't change too much, then maybe we can train the DNN offline, then we can put it online to implement it. But if the environment change quite a lot, including the statistical property, then it should be very challenging to use DNN. So, but currently the research work only use simulation based. So maybe it would be. There are some learning based methods for the real measurement, but it's quite simple. They just check some angle of arrival and the angle of departure for the channel. But for the pre-coding decoding design, I think currently no practical implementation. Yeah.
What about the transfer learning model? Is available? Transfer learning, like ResNet or some model available that we can apply, so reduce the training when we have only small data, the amount of small data.
Yeah, if we have only small data and transport more learning.
Yeah, usually computer vision people use transfer learning.
Usually, if the data is small, it will be difficult to learn to train the model. Yep. It depends on how many parameters you want to train and how many input data. The dimensionality of the input data. So if the dimension is not that small based on my experience, maybe it is insufficient to train. But maybe sometimes if we reduce the parameter we want to generate for the output, maybe it is feasible. It based on the whether the system is complicated or not. Yeah.
Okay, thank you very much, Professor.
Thank you.
Okay, thank you. So, is there any questions? Maybe one more questions due to the time limitations, I think. Or is there any question from online audience? Okay, I think just the last question, I think, from me. I'm curious more about the green learning. Can you explain more what's green learning and what's its advancement? I mean, its benefit compared to the conventional learning.
Okay, green learning is actually you can treat it as some lightweight machine learning model. For typical machine learning, we just put everything inside the model and we train the output. Or for the deep learning, we put everything to the neural network and then we get the output. But for deep green learning, we first pre-process the input data. We find the dominant, the important feature. And after we extract those important features, then we use it to train the model. So the model size for the decision making will be much smaller. So this is why it can take fewer power consumption or computational power. Yeah, so based on, because the green learning has been adopted in multimedia for several applications, and usually it takes, compared with DNN, CNN, or some other deep learning based model, it usually requires 1% model size or 1% of number of flopping point operations.
Okay, thank you very much
Thank you so much.
for Prof. Huang. Thank you for your sharing your expertise and for engaging discussion during Q&A. And this is the end of the session, the third keynote speaker. And please once again give applause to Prof. Huang.
Yes, thank you to Professor Huang and Dr. Sirojudin. But before we continue, I would like to invite a representative of the ISITIA committee. Oh, Professor, may you please be on the stage for a few moments? Yes. We would like to give a token of appreciation to Professor Huang. Perhaps Dr.rer.nat or maybe Dr. Puji to give a token of appreciation to Professor Huang. Yes, once again, thank you to Professor Huang for the insightful presentation. Ladies and gentlemen, next, we will have our fourth keynote speech. Let us welcome our fourth speaker, Dr.rer.nat Teti Zubaidah from University of Mataram, Indonesia, along with our moderator, Dr. Rosmaliati STMT, also from the University of Mataram.
Ladies and gentlemen, may I have your attention, please? We are now in the fourth presentation, fourth speech. Will be topic of mitigation of catastrophic technology failures due to geomagnetic storm. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Before we go to the speech to introduce the speaker, Ibu Teti Zubaidah, a whole bachelor and master degree in electrical engineering, while her doctoral degree is in geophysics with geomagnetic expertise. She obtained a promotion urkunde, I don't know how to pronounce it, with the title of Magna Cum Laude from the University of Potsdam, Germany in 2010. She conducted her doctoral research at geomagnetic section of Geoforschungszentrum, GFZ. I only can say GFZ, Potsdam University from 2006-2010, and her special expertise in the field of geomagnetic for earthquake or hazard mitigation, regional tectonic modeling and analysis, and geothermal energy exploration. Ibu Teti is like have expertise combination of natural science and electrical engineering, of course. She has initiated an international cooperation to establish the Lombok Geomagnetic Observatory. We have one of observatory in Lombok established with collaboration Bu Teti as representative of the University of Mataram and GFZ. Maybe if you visit Sade, Mandalika tomorrow, maybe you can also see our observatory. Maybe the one of the geomagnetic observatory in Indonesia. And she is also head of Center of Excellence in Science and Technology and on geomagnetic. And also she is an expert in disaster mitigation and actively involved in professional organization. She is also a head of West Nusa Tenggara Asasi, IEEE member, and HIPTI Bencana, as well as alumni of the AAD scholarship holders. Actually, there are another activity of Bu Teti, but because we have only short time to explanation, I just explain the short bio. So the next, I would like to welcome Ibu Teti to give your speech, maybe around 30 minutes. Please take your time.
Okay, thank you very much for introducing me, Ms. Rose Maleti, and thank you very much for having me in this very happy occasion of ISITIA 25th in Lombok. Okay, so I'm Teti Zubaidah. I would like to present about geomagnetic storm, which is maybe not a quite new theme, but in today's life is quite important and more and more important theme to be discussed because it's actually related to catastrophic technology event and failures, and what we can see that day by day the failures is increasing. Okay, so I don't know how to use it. May I have, okay, thank you. But I think the lesser point is not work. Or maybe I have to use it here, no? Okay. So, on our daily life, we observe the sun, sunrise and sunset regularly, but actually the solar itself or the sun itself is quite active, and the activity of sun is pretty what is it? It's quite difficult to be captured by our eyes, but with the technology, we can see that. Please go back to the first. Yeah, we can see some of sunspot here, which is the manifestation of the activity of the sun. Or maybe if I need laser, I can take this. Okay, thank you. And here is the solar flare, because many material of solar, which is gas, and with the reaction, nuclear reaction, they come to the flare like this, and mass ejection. Oh, so coronal mass ejection can be observed not all the day, but in some days of this year. You can see, and every 11 year, solar has cycle. So we call the solar cycle every 11 year, and we will have the coronal mass ejection is huge mass rather than the rest of year. Okay, so we go to the next slide. Actually, our Earth here is shielded by electromagnetic field or geomagnetic field, because our Earth rotating with a huge mass of steel in the core, and because of its rotation, the magnetic field is generated on the surface of Earth, and also come to the constellation star. And here is the interaction between the sun and our Earth. So if the sun active, and in some days they eject coronal mass, and our Earth react like this. So if no coronal mass ejection, the geomagnetic field should be in a linear fluxes, with the day and night side is equal. But if the sun creates some coronal mass ejection, so in the day side, the form of the shield is like depressed, and the night side it's make a tail, like a tail. Maybe you can imagine comet, a comet. So a comet always make some shape with a long tail like this. Okay, and here is the more detail about the geomagnetic field, how it protects the Earth. If we have the geomagnetic field, so if sun comes with solar wind, and the wind will deflect to another part of sky and reaching far from Earth, while maybe some solar wind can induce to the magnetic shield, and then here in the polar side we have aurora. So maybe I can repeat it. Yes, like this, and the aurora will be formed here in the north and in the south side of the Earth, South Pole. And the rest of Earth, however, is protected, because the solar wind cannot reach the rest side of the Earth. So why the geomagnetic fields called protect the Earth. And here is the real recording of the GMEs. The last GMEs has happened during mid-May in 2024, and how the corona is very huge, reaching the sky, and the aurora itself can be observed in many places. It's very phenomena actually. And next, okay. Here is scientific data of May 2024 GMEs and geomagnetic storm. So I take from the GFZ. Actually, GFZ is Geoforschungszentrum, or the Center of Excellence in Geophysical or Geoscience in Germany. So they take the data here from January, February, March, and until today, yeah, here. And we observed that the KP is the index of geomagnetity, which is range from 0 to 9. And the range here is a level of activity. So it is very severe. During the magnetic storm, beginning in 10 of May until 12, yeah, about 12 of May. Okay. And then here also the geophysical volcanology in Italy report the same thing. And okay, maybe I have to be here because if we observe the data, so you can see some level of missing of threshold level of X-ray flux during of geomagnetic storm and also before. Yeah. It can be concluded that there is a relationship between the activity of the sun itself with the geomagnetic observed in our Earth, like this. Okay, and then we go to next slide. Here also a data from GFZ in mid-May 2024. It's recorded as the strongest storm in the last 20 years and caused significant impact. If you back to here in 1932, so the sunspot number can be recorded like this. So here's daily sunspot number in yellow with 11 time interval of cycles, and then we are reaching the last cycles here. If it's make a yearly sunspot number, average it, and here is average of KP index, so the geomagnetic index, the geomagnetic observed in the Earth, which is index is 0 to 9. So we can observe the similarity or the equivalency with the sunspot number. Also here, if we go to frequency of KP index, beginning in 1932 to today, we can observe that here is the May geomagnetic storm and the last geomagnetic storm with same quality or same level is 20 years. So it's the strongest storm in the last 20 years. We see like this. But actually the most strongest event, not here or here, but somewhere in 18th century. Okay. So here the observation of geomagnetic field we can access with the intermagnet data. You can also access it freely in real time. And if we go back to the May event, I take the data from KKDU in the North Australia and here in West Australia and one station, observatory of Cocos Island, just near Indonesia. We can compare the three observatories, and all of the observatory also see the differences in unusual daily value of geomagnetism, because the normal daily value is like this, yeah, or like this, but during the storm it's quite disturbed by external field from the sun. Why I put the three observatory? Because in the term of geomagnetism, the geomagnetic storm is, and if you remember the aurora, so the aurora is concentrated on the pole, northern pole and southern pole. it's quite far from this observatory, the tree observatory. But on the occasion of May 2024 storm, the storm itself can be observed in the equatorial region, near the equatorial region. Means that the storm is quite huge or quite powerful to to modify the geomagnetic field of Earth. Okay, so it become in our mind that so the storm is a dangerous event for our daily life. And then next here is our data. This is primary data of our student. In the disaster of mitigation, Magister of Disaster Mitigation, I and some students conduct the geomagnetic observation. This just a real case, and actually it's quite simple. You can also use your smartphone. Maybe some of you do not know that your smartphone can be used also for geomagnetic measurement. But you can try. You can try to use CrowdMark application from National Center of Environmental Information or NOAA, and then you can get, if you observe in 1 hour in a day, maybe you can get like this, just a daily magnetic value of your location. And here with 5 of students in University of Mataram, we observe also the impact. Maybe it can be here, geomagnetic storm in 11 May. So the impact of the storm can be recorded in our data, with the decreasing of intensity, and also here the horizontal intensity is much decreased, and actually the vertical intensity also decreased. Because the number is negative, so it's like increasing but actually decreased. Okay, next. What are the serious disruption can be caused with the geomagnetic storm? I listed here only 6 of infrastructure technological systems that can be affected by the geomagnetic storm, but actually maybe many more, and we will observe many more in the next year. The first one is actually satellite. Yes, it's very clear. And the communication system, internet network, navigation system, pipeline system, and especially electrical power system. Okay, so we go here one by one. I would like to shortly talk about the phenomena. So if we get a closer look about the interaction with sun and the earth, here is the earth, and here the fluxes, the electromagnetic fluxes comes to the equator, the polar region here, but some of the fluxes come in the tail like that, But the most particle, the most energetic particle will be trapped around the ring, around the Earth, and makes a ring current here, which is in ionosphere. Actually, in the ionosphere. Okay, and if we see in the three-dimensional view of the energetic particle, we trap in ionosphere, so maybe like this we can see, and the satellite is actually orbiting in the ionosphere. So during the geomagnetic storm, the satellite is very vulnerable to the geomagnetic storm. Next, please. Okay, so here is the satellite which is orbiting the Earth in ionosphere, and the satellite itself uses the solid state technology, which with PN, gate, drain, and source. So if the satellite with its trajectory come very fast, orbiting the Earth in ionosphere, and then here the trajectory is single fast moving, it can impact the voltage or some electronic part in the satellite, and it can damage and phantom command or damage to electronic or loss of control or even satellite failure. So satellite failure is reported in 1994 due to geomagnetic storm on that year. So here many satellites, 1, 2, 3, 4, 5, 6, 6 satellites has failed during the storm. Okay, and the second one is disruption on communication system. It was begun during 18th centuries in 1854 with chemical telegraph, because the chemical telegraph used the pen and with the chemical reaction to make a color mark on the paper to have a written paper. But because the current induced by the geomagnetic storm and then also flow to the pen, which is the pen is metallic actually, and then follow the increasing of current produce head of thermal and flame of fire to the paper. So many of telegraph machine have burned on this event and reported, documented scientifically. And later on, the phone system also has damaged when human search a new technology and then go to the phone system. But the phone system itself have breakdown voltage, is higher produced with the geomagnetic storm, and was happened in 1940 with 50 volt increasing in voltage on the telephone line and made damage. Okay. So, and then with the coaxial cable, how with coaxial cable, continental cable, submarine cable, even fiber optic cable, all actually are vulnerable with the geomagnetic storm, because the coupling between cable and the ground, let's see here, maybe a seabed ground point, it can make a loop, circular loop here by induced current from the geomagnetic storm, and increasing the voltage in the output, and it make the system unstable or signal error and something. Let's also talk about the internet. Today we cannot be separated with internet, and internet itself is demand with satellite and also cable, internet cable. So the most same thing or thing of vulnerability can be observed in internet network. Okay, and next one is the navigation system failure. Why navigation can be disrupted by the geomagnetic storm? Because here, for example, the GPS receiver use radio signal, and the radio signal with the orbiting of satellite in ionosphere. I have said that it's much vulnerable with the geomagnetic storm. But if the satellite itself is still can be operated normally, but the what is it? The propagation of the wave from satellite to the receiver can be disturbed by the electron content in the ionosphere. Because the electron content in the ionosphere is not similar from time to time and also based on the space. So here irregular total electron content makes, for example, in some part the signal come faster, and in another part here come slower, so have a delay, propagational delay, and produce the error of range of the GPS. Maybe this very close to your daily life, yeah, because if and maybe someone can remember in mid of May, while ordering something from online platform, and our location changed. Yeah, our location is far away from our house, like this. So this is the impact, yeah, of the geometric storm that can be observed daily. But maybe this is just a small case of observation. If you think about navigational system in aeroplane and also in marine transportation use, it will increase the disaster, yeah, the disaster potential. Okay. Next one is the corrosion of pipeline or system, because the pipeline of long pipeline, which is used in transportation of gas or oil or water, is come from steel, and it can have to be protected with a cathodic system to avoid the corrosion. So the cathodic system is like this, yeah. So this is power source, and this is ground bed, and here connected to the pipeline itself. And during the geometric storm, the current from the sky also induce, yeah, to the system and produce more voltages in the cathodic rectifier. So the cathodic rectifier may be in the dangerous level, because here in a quiet time means no geomagnetic storm, and here is magnetic storm, and the rest one is quiet. So during the magnetic storm, the voltage can be reached unsafe region and risk the possibility of corrosion, of course. The last one is disruption of electric power system. So if you see here the transmission system or with transformer and also not part, yeah, like underground pipeline and railroad tractor, the GIC, we call GIC, geomagnetic induced current, yeah. GIC can flow over this line, the metallic line, and create many phenomena here. With this GIC power system, it increases reactive power loss, harmonic distortion, or even transformer overheating. And with the concern of voltage drop, or you have a direct change of generator and reactor and transformer failure, and produce system instability or even blackout of the system, total blackout of the system. Okay. So how about our magnetic event in May 2024? This is some report, and confirm that the geomagnetic event make some impact and can be recorded and affected the operation of power system in the Northeast America and Mid-Atlantic America and Western Canada. Fortunately, in Indonesia, was not reported, but we have to be more watched about the geomagnetic storm because why? Because the magnetic field itself is weakening. Magnetic field of our Earth is decreasing time by time. Can you see here from 16th century to today, and with the part of the weakening in blue color is coming grosser and grosser, and also Indonesia itself, you see, will be affected of this weakening. Why the weakening related to the geomagnetic impact? Because as you may recall my presentation on the first slide, so the geomagnetic field of Earth is like a shielding of our Earth, and or like an umbrella. So the umbrella is weak, and the drop of rain is quite strong. So you can imagine, how it can be. Okay, so next, please. Oh, no. Previous. Here is our data, our primary data in the geomagnetic Lombok Observatory. As Ms. Rosmality said, that we operate the observatory this from 2014 to 2017. A, B, C, and D panel show the decrease of intensity, magnetic intensity in Lombok. And it's confirmed that the weakening of geomagnetic fields also happened in this area. And with the decrease, much more compared to the another region in Indonesia. Okay, next, please. So chronology of the GMD event can be described from 1840 to 2020. And if you see here, the most impact on telecommunication is in telegraph. And then we in 1920 changed the telecommunication system to another way, not use again the telegraph, but then the impact can be observed clearly in power and railway system because of more longer distribution and transmission system, and also quite big and bigger generator transformer with a gigavolt, like this. So the vulnerability is increasing, during the time, and the reported cases is also increasing. Okay, next slide. One of the what we can discuss is the case of New Zealand, because New Zealand is also in the equatorial region. But on this side, it can be observed also the GIC and the failure of power system on this area due to geomagnetic field, geomagnetic induced current around New Zealand, explored with the GIC. Okay. Next. So, how to mitigate the vulnerability itself? In North America, they built a reliability corporation and specialized to deal with the geomagnetic event. Because on this area it's quite important to do this. They make a transmission system plan performance for geomagnetic disturbance events, and the assessment is quite rigid with here the observation of geomagnetic field and also the modeling of power system itself, and go to the operating procedure. Next. Here, what I want to say is the geometric variation itself. The geometric variation itself have to be observed regularly in a continuous manner to get the geomagnetic data, and it's an important input to the convolution or impedance measuring system, and we can describe how the geoelectric field or geoelectric hazard can be or should be. Okay, next. On this white paper of the NAERC, we see two kinds of vulnerability assessment, which is one is benchmarking and the other thing is supplemental. The benchmarking is only like the quantitatively use the longitude and latitude of your location and put on the equation, and you can get the electrical field. I mean the electrical voltage that can be induced on your system in volt per kilometer. Okay, but actually we also need the requirement R12 on this standard, and should obtain the data accessibility locally and also with the reliable data from the observatory or research institution or academic university or entities that install the geomagnetic magnetometer, the geomagnetic equipment or magnetometer, to do the real assessment, and to get the real value of how much voltage can be induced. Next. Here is also the example. So the geophysical survey have to be done with magnetotelluric on some area, for example here in America. So they do the magnetotelluric survey and can map the low and high resistivity area, which is the high resistive area with blue color is much more severe with geomagnetic storm because the voltage are increased, because V is I times R, I times R. So current times to resistivity. High resistivity mean much more vulnerable. And here is in the North America, for example, and the east part of America is quite vulnerable. With this modeling, or the calculation. Okay, next. Oh, here's the remark of my presentation. So, system to be more robust and resilient, to be prepared to the next geomagnetic storm, and monitoring geomagnetic activity and forecast is quite important for today. And also individual also can be participate, We prepare ourselves, having an emergency plan and keep prepared for the next geomagnetic storm. Okay? Thank you very much, and be prepared and stay safe, stay calm. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Ibu Teti, for interesting speech. Yeah, actually, it's a little bit difficult to understand for the public, But now we are in the scientific discussion right now. Now we come to the question and answer session. I would like to invite the participant to give a question. Please raise your hand and mention your name. Hand up, please.
Okay, thank you, Prof, for your enlightenment to me because I never heard about geomagnetic activities and such as geomagnetic storm before. So I just wondering, can we monitor the geomagnetic activity real time? And if so, what peripheral, what sensor we use? Especially not for the large infrastructure, but related with for example, if individual want to know about geometric activity. Thank you.
Okay, the standard equipment to monitor geomagnetic field, we use magnetometer. It's also used in all observatory in the world and also geometric station. So if you like to know about the magnetometer, maybe you can visit our observatory here. But for your question about the individual awareness, as I said that you can just use your smartphone, maybe Buros, you have your smartphone and you can download from your Play Store, CrowdMark. I suggest this is one best application to be used because we actually have some application, including PyPOC from the RWTH, what is it? RWTH, Aachen, also prepare the application, but the application from NOAA is quite good, and we have used it as I demonstrate. The data is also reliable, so you can download the application and just try, and monitor the activity around your place or location. And I hope you can see some phenomena. Okay.
Thank you. I also noticed I got application in IoT that utilize the magnetometer that available in some mobile phone. It is okay?
Is it also okay?
So for example, double I got IoT application. Usually when I teach my students, for application IoT, the simplest one is from double application, and there is magnetometer. Can it sense it?
Yes,
even
of course.
Okay.
Of
Okay,
course,
excellent.
it can send the event, but why I recommend the software, because the software is
Specific.
specifically designed for this, and you can use it as your sumbangan, to the community. So actually here we have developed a community scientists in geomagnetism, and if you want to share your data, not only for you, but to all over the world, you can join the community, and the application is support to do that, because your data reported to the NOAA, and they collect the data anonymously, of course, yes. And also the location itself is something not a precise location, but like a symbol of Lombok maybe, for my data, and Lombok, East Lombok, West Lombok, or not Lombok, not my home, not my home, recorded on this global data. But then we can share, and we can also get another data from all the people in the world like this. It's quite interesting and quite useful, I think, for the community scientists to be involved in such observation, community observation, maybe not really scientific observation, but community scientist observation.
Okay, thank you. One more question, the last question. Is there any methods or something that can avoid geometric storms, such as for example, we call it, if we can call geometric gates, something like Sankar Faraday or Faraday gates, something like, to avoid damage, Thank you.
Yes, it was also the idea of scientists to do that, but actually the method maybe cannot work for of the globe because it's quite huge infrastructure and maybe not realistic to be developed. At least in the places, or if you have very, very sensitive infrastructure to the geometric field, you can do that only to this place. For example, maybe you are very afraid that this device can be disturbed by geometry, so you just make a small Faraday cake, like maybe the antenna cake from Professor. Yeah, it can be used. It can be used actually.
Okay, thank you very much.
Okay, thank you very much, Pak Hendra. I would like to invite the other question. Maybe,
Hello, good
Pak
afternoon.
Dedet, please. Yeah, maybe there is a question from online.
Yes, there is a question.
Okay, the first I would like to give to Pak Dedet first.
Thank you very much, Dr. Teti. It's quite interesting presentation. The standard of the electromagnetic compatibility for electronic devices. Thank you very much.
Okay, that's very important question. But the decreasing of geometric field itself cannot be avoided. It's naturally, naturally as a system. It's also maybe related to the rotation of Earth itself is changing, and also in the core of Earth, the mechanism of flux generated is also changed. So we cannot avoid this. This is just a phenomena, and we can just observe the phenomena. Okay, this the first point. The second, maybe we just have mitigation technique to avoid more damage to our system today. Maybe we have to think about new technology. For myself, we have to think about new technology, not only depend on solid state technology, because solid state technology in the next days will be very vulnerable. So we have to search, research and search new innovation about to change the technology. Like the telegraph, okay? We learn about telegraph. Telegraph is on 18th century is very maybe excellent technology, but today we cannot use it. Yeah, we have to change to the phone and to the internet, and maybe internet also will collapse, maybe. Okay, and then we have to search another innovation. It's a mitigation of in technology. The third one, maybe the robustness of the robustness of our devices, and it related to the standard. So I just suggest to IEEE to review the standard of electromagnetic compatibility, okay, and set the new level of compatibility. Maybe now 10 microtesla is enough. Yeah, 10 microtesla is enough. But the next year or 10 years after that, maybe we have to make it a higher level like this. Okay, I hope it's answered your question.
Okay, thank you, Pak Dedet. Maybe for the next question, how to show the question? You can show in monitor. Okay.
Hello, good afternoon, Dr. Teti and Dr. Ross.
We cannot see.
I am Bu Vita from ITS. Yes, how are you? I hope you're good. Thank you very much for the new information for me. I'm interested in your affiliation. It is Magister of Disaster Mitigation under Electrical Engineering Department. So I wonder, can you share, is this a multidisciplinary program, or is it mainly electrical engineering? And if you have research thesis for master and bachelor students, can you share some examples of these theses related to this topic? Thank you, Dr. Teti and Dr. Ross.
Okay, thank you, Bu Vita, for your question. And quite new that just found in 2022. Yeah, the end of 2022. So we now is still in the third semester. So if you ask me about the thesis or the thesis, we currently don't have any product of thesis, but currently we have we have running first year of the thesis for the first semester, the third semester of student. And if you would like to be involved or to be collaborated with our department, it's quite welcome, yeah, because the department is multidisciplinary. And maybe I have to correct the information, because the Magister of Disaster Mitigation is not under the electrical department at the University of Mataram, but at the postgraduate program of University of Mataram. So in postgraduate program of University of Mataram, we have 8 departments. All of departments are interdisciplinary science and technology. So you can, of course, involved in the networking or next, the next dissertation or thesis. Okay.
Or maybe, Bu Teti, you can explain before you go to the mitigation, magister mitigation. Maybe you already introduced some bachelor thesis in electrical engineering related to the mitigation or geomagnetic. Maybe you can also introduce this topic. Bachelor thesis.
Oh, okay. We have also bachelor thesis regarding the geomagnetic activity. Some of them are produced with primary data of Lombok Observatory, but some other is with the Intermagnet Observatory. So it's quite a wide area, and also with many signal processing method, like the trended fluctuation analysis, and also differential analysis, and also fractal analysis. We have used also wavelet and so on. If it is your subject, so maybe we can collaborate in this term. Geomagnetic for geothermal exploration, not only for earthquake mitigation. Okay.
Okay, thank you, Bu Teti. Is there any other question? Okay, I think because the limitation of time, I would like to end this session. Thank you very much, Ibu Teti, for your interesting speech today, and thank you very much for the participant to have like interesting discussion, especially this topic is maybe almost new for us, and then this is potential for us to make like a collaboration, not only talk about the electrical engineering itself, but also how to combine with this kind of topic. Thank you very much. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Good morning. Good afternoon.
Thank you to Dr. Teti and Dr. Rosmaliati. I'm sorry. But before we continue, Dr. Teti, may you please stand on the stage for a few moments? We would like to give you a token of appreciation. Now, I would like to invite the representative of ISITIA committee to give a token of appreciation to Dr. Teti. Perhaps Dr. Puji, would you like to give the token to Dr. Teti? Once again, thank you to Dr. Teti. Ladies and gentlemen, we have concluded all our keynote speeches. After this, please take a moment to do your lunch break, and we will continue with the next session with a workshop on community development. The workshop will start at 1 p.m. and will be delivered in hybrid mode. And the speaker, Dr. Chanakya Kumar, from the Siddhant Group of Institutions from India, will be present here to share about proposing humanitarian projects, especially related to IEEE and SDG. So make sure to come back and join us again after lunch. Thank you. And before we have our lunch, may I please request you to come forward.